formed in the sands. For these impression, extra projection are provided on the pattern surface at the proper place. These projections are known as the core prints. The extra projection on the core are known as the core prints. Now core boxes, how to prepare the core? These cores are prepared in the different type of boxes according to the need, which type of core we want. So we choose the different type of boxes. Boxes which are used for making the cores are known as core boxes. It also can be defined as the pattern for making the cores. Different type of core boxes are half core box, dump core box, split core box, left and right hand core boxes, loose piece core boxes, sticker type core boxes, and gang core boxes. These are the some of the different type of the core boxes which we are using in the foundry industry. Now core material. The core material is core sand or the granule refractory, core binders, water, and the special additives. Core is made up of the specially silica sand or the green sand with the granular refractory. Refractoriness of that particular sand should be very high because it comes in contact with the direct molten metal. Core binders, different type of core binder. These should be the oils or water or dextrine, or there are various type of the core binder which are used to just grains of the sands to keep them stick together with the each other. So these core binders are used in that case. Water is used 2 to 7% just to bind, give the moisture to the this sand, granular refractory sand. Some of the special additives like molasses, wood dust, coal dust, sea dust, special additives are used just to strengthen the core. Now core making procedure, how to prepare the core. Core sand preparation. The core sand is specially prepared with the help of the roller mills. These mills just produce the sand of the exactly same dia. These sands are prepared by the roller mills in a different heap, and this sand is specially used for making the cores. Second is core making. We just put the core into a box, any of the box which we want to make the core. We just squeeze the that particular sand in the different parts of the box. The fluidity property should be high in case of the core sand. So sometime we are using jolting or the squeezing machine in case of preparation of the core. After putting it into the core box, we just drag it out from with the help of the wires or some of the dowel pins. After getting out the core from the core box, we just keep it into a oven just to heat it or bake it. Third one is core baking in the different ovens. When we bake this core and make it strengthen and just put out the moisture content in these sands, the core baking process is done. After that, core finishing process is there. We just finish the core with the help of the filing and make the exactly size of the core which the hole we want in the casting. So this is the core making procedure: sand preparation, core making, core baking, and the core finishing. Once the core is in our hand, we just put it up in the mold and molten metal is poured. After the metal solidify, we just keep out this core, and a hole or a projection or a slot is produced in front of us in the casting as a result. Now next is the chaplet. Core is sometimes held in the molding or the molds. Sometime it is suspended in between, or sometime it is leftward or sometime outward. Chaplets are provided just to give them the extra support, because cores don't have the contact with the mold directly. These are the extra projections given in the mold. So these are held with the help of the chaplets. A core chaplet is a metal piece inserted into the mold either to prevent the core shifting from the position or given an extra support. When molten metal is poured from the runner or riser, this molten metal enters in the mold. This core could change its place from what position it is gaining. With the help of the chaplets, we can stop this movement of the core. These chaplets are made up of the same material of which the casting is produced. These chaplets solidify in between that casting material, and cores are removed back, but these chaplets are not removed back from the casting. The different type of chaplets are here. You can see the radiator chaplets, cast chaplets, stem chaplets, and double head chaplets. These all chaplets remain inside the mold and solidify within the molten metal. Now next one is the molding sand. The molding sand is a necessary part of the foundry industry. So this sand is basically responsible for producing the molds in which the molten metal is poured and casting output is given in out from these molds. What exactly the mold is? Mold is a cavity provided in the compact sand mass with the help of a patron. A patron is responsible for producing the mold as well as for the casting. Molding, it is a process of making the molds from which casting are obtained. Molding is a process from which the castings are obtained. Molding materials are such as steel, anodized aluminum and grey cast iron, and known metals are sand, graphite and the plasters. Molding sand. The various constituents of molding sands are silica sand, sand binders, additive materials and water. Silica sand is basically consists of silicon dioxide. In the silica sand, in the molding sand, we got the silica sand, which the major contents of that silica sand is silicon dioxide, which is around 85% to 86%. Then there are the different sand binders in that could be the coal dust, that could be the wood dust, that could be the sea dust. So all these binders are used just to make this silica sand to stick together and make a very hard mold. The clay is basically used as a sand binders. In silica sand there are moisture contents are there, silica alumina oxides are there. These are also the contents of the silica sand. Additive materials are dextrine, mineral oils. These are the additive materials in the case of the molding sand, and water content remain from 2 to 7%, which makes the mold a very moistened or the strengthened. Now the types of the molding sand. Natural sand is there. It is achieved from the seashores or the on the bank of the rivers. It is one of which contain the sufficient content of the clay as it is taken from the river bed. These sand we got naturally, that's why these are known as the natural sand. Characteristics of the natural sand: it can be readily available for use from its source. We can directly use the sand getting from the banks of the river. We can directly make the molds of that, because binders are there, moisture are there, clay is there mixed. So we can use directly the natural sand without any additives to the molding process. This contains the binding material 5 to 20% clay. As I told you, clay is used to bind the grains of the molding sand with each other. Clay acts as a very good binder in case of the natural sand. It permits easy patching and finishing of the mold. Mold made from the natural sand is finished very well. It can be easily repaired. If in any case it get destroyed, it could be easily again repaired or again made. Synthetic sand, it is an artificial sand obtained by mixing of the relative clay, free sand, binders and other materials as required. A synthetic sand is also known as special purpose sand because in synthetic sand we can mix the clay and other binders and materials up to the contents we want as a result. It consists basically of the natural sand, binder, moisture. So as per our requirement we just make the sand and produce the casting. The characteristics of the synthetic sand, in the case of synthetic sand we use lesser binder materials, reusable sand, because this sand we can use again for making the molds, more uniform grain size. As this sand is synthetically prepared, in natural case the grain structure could be different, one granular structure of the sand could be different from the another, but in the case of the synthetic sand we make almost same size of the grain size of the sand. These can be controlled by varying the mixture contents, the moisture, the binders, the extra material induced in the synthetic sand can be controlled by us because these are artificially prepared sand. Next one is the loam sand. The loam sand contains much more clay as compared to ordinary molding sand. The clay portion in case of the loam sand is 50% to the green sand. The green sand contents are 50% and 50% is clay. So this make a mold very strengthy. So these loam sands give the very good casting. Characteristics of the loam sand, it is used for molding of the large grey cast iron because of its clay contents. Clay contents are higher, that mold is also very strengthy, so that's why we can make to produce the large grey cast iron as a output. Loam dried very hard, sweep or the skeleton pattern may be used for the loam molding. While using the loam sand we can make the sweep and the skeleton pattern very easily. Special sands, it contains the mixture of the organic compound. Cost of these sands are more, but these offer high temperature stability, better cast surfaces. Special sands are special purpose sand which are used to react with the high temperature of the molten metal. So temperature stability is there, better casting surface, better finishing is there in case of the special sand, as special properties are induced in case of the special sands. Various special sands are zincon, chamois, olivines, etc. So some of the other technical sporting sands are facing sand, baking sand, parting off sand. There are different types of sand which we are using in the foundry industry. Some sands are used when pattern is entering in the mold, some sands are used when the pattern we are drying out from the mold. So there are different types of sands used in the foundry industries. Now coming to the properties of the sand, what are the properties should be induced in a sand so that we would get the very best casting. First property is porosity. The sand must be porous to allow the escape of an air, gas or any moisture present in the mold. The sand grains or the sand should be porous one. Porous one means it should allow the gases produced by the molten metal coming in contact with the sand or moisture, then certain reaction is produced, various fumes or gases are produced at the entry of the molten metal. These gases is to escape from the sand boundaries. If there is porosity properties there in the sand, these gases will escape very easily, otherwise they will break the mold and our casting process will come to an end. So so the sand we are using in the foundry industry should be the porous one. Next one is the refractoriness, the ability of the sand to withstand the high temperature without breaking the mold. Refractoriness is the property of the sand which a sand should have in it, because molten metal temperature is very high. It should withstand with that temperature or bear that particular temperature, otherwise the mold would break up and our casting process would come to an end. Next property in sand should be cohesiveness. The sand should have the property of the cohesiveness. This property of the sand is when the one granular particle of the sand attached to the other particle, this property is known as the cohesiveness. One particle of sand attached to other one and make a strong mold is known as the cohesiveness property of the sand. Next one is the adhesiveness. Adhesiveness of sand is the property in which the sand particles have the property to attach to the other material. If in the case of the cope and drag, the sand particles are attached to the cope and drag portion very well, so that would produce a very good adhesiveness property. Not only the sand particles stick together with each other, but to bind to the other portion also. That property is known as the adhesiveness of the sand. Last one property of the sand is flowability. The ability of the sand to behave like a fluid so as to distribute properly. When the sand is put up in a core, cope or the drag portion, and this sand is rammed with the help of a rammer, it should reach to the each and every portion of that particular core box or the cope and drag portion. So this property of the flowing of the sand from one point to another point and to the all points is known as the flowability of the sand. This property should be there in sand to make the proper mold. So all these property should be there in a sand which we use in our foundry shop: porosity, refractoriness, cohesiveness, adhesiveness and flowability. So these are some of the properties of the sand. With this we come to the end of pattern making and the properties of the sand. In the next lecture on 21st October, we will discuss what are the different casting defects and gating system of the pattern making in the mold making. So up till now, keep hard working students. Thank you.